we so whether you are in Python or in Node.js or in Ruby on Rails, you can be able to like create special functions that check or authenticate users so that you are able to like know this is the owner of this account. So for the smart contract, we use modifiers. So modifier can be of any type, can be a condition. Most of the times, modifiers are conditions. They act like conditions. They are conditional functions. So yeah, so function called modifier. You can apply modifier to functions by adding the modifier name in the functions. So modifiers are most often used to create conditions that apply to many functions. So if instead of like creating, you need to like check the withdrawal value. You need to also check the withdrawal value. So instead of like repeating the same for every function, like instead of repeating the conditions, you just write a modifier function, and then you pass your modifier function at the end of the function, So and then we did see the event logger. So this one will emit an event, an address event, and this one will emit a unit or a uint or a integer event. Yeah. So that's what we did yesterday, and those are some of the things that we talked about: deterministic contracts and undeterministic smart contracts, and also global predefined variables and functions that are available in Solidity. And yeah, so today, and I also did a warning on about gas. So the more you are there are those loops like just a minute, let me show you a loop which is a continuous loop. There is a continuous loop that it's called, so for a never ending for loop. So this one is a never ending for loop. It doesn't actually end. It's an infinite loop. Just the way that we have numbers that example of an infinite loop. Just like the way we normally have. So this is this one is an infinity loop. It's an example of an infinity loop, and it will continue at even at and until the system, if it will continue as long as the system is online or is working. So for loops, if you are creating loops, be careful not to create infinite loops, because the more you are using loops, the more gas you will be using on your smart contract. So you need to be careful on ghost, because on your loops, because as I mentioned in the previous lesson, that was on Ethereum and gas price and gas fee. If you have a continuous loop, you will use a lot of gas, and Ethereum functions on transactional based on operation. So which operation are you doing? Yeah. So we also did look at Boolean expression variables. This one is a state and local variables. So state and local variables are in storage by default, like this one. Mapping is already something which has been which has an already predefined storage by default. And then we have mappings. So mappings, this is what I said that we will do. So mappings are only allowed for state variables. So mapping can be as a hash table, which are virtually initialized such that every possible key exists and is mapped to a value. So we can, yeah. And then we have this one, global variables. So these ones we talked about, the address of the sender in the current call, the amount of where sent with the message, and the current time. We also talked of visibility for functions and state variables. So we talked about public can be called either internally or from messages, default functions. So this one can be called internally within the smart contract. Private can only be called from the contract that it is defined in and not from derived contract. So if a function is private, it cannot be used in another contract. It can only also be used in the same contract. Public can also be used in another contract. Internal can be called from this contract it is defined in, is derived in, all in derived contracts. So internal function can be both internal and can be called from the contract it is defined and in or in derived contracts. So it can be either, like the case of libraries and interfaces. Then we have external, can only be called from other contracts and via transactions. So external can only be called from other contracts and via transactions. Then we have inheritance. So we did inheritance, and we saw how you can do inheritance in Solidity using the keyword is. So the code from the base contract is copied into the final contract. And an example was use is to inherit from another contract. So contract owned, you can use the function contract motto is owned, and then function kill. If message.sender equals owner, then the contract should be self-destruct. That is the only person who can do self-destruction of the code. Yeah. Then we have multiple inheritance is also possible. So you can inherit multiple contracts in the final smart contract. So most of the ERC20 token mostly have multiple inheritance. So one contract can have multiple inheritance. So think of multiple inheritance as all inheritance as the genealogy, all the DNA of a person. So the child who is like now, if you are a fourth generation kid or the third generation, probably you have multiple inheritance of different grandparents. Yeah, because yeah, you have inherited features from different grandparents all the way, and they can also be passed to your generation. So it's the same case for inheritance. So this one would be like the first contract, having inherited the contract that was owned. That is contract one, which was owned, and then we have another one, base one is motor. It has inherited another contract from in a different in a different contract. So it's possible to have the final contract inheriting from all these other contracts. Yeah. So then we had the use of super to call the next position in line in the inheritance hierarchy. So if base one calls a function of super, then it will call it on base two rather than on base one. So let's see. Then we have destination address dot send all current address dot balance. So when you use destination address dot send to send WEI to a destination address from the current contract, and we can use current address dot balance to check the balance of the current address that is. Then we have bytes 32. Each byte 32 can store up to 32 letters. So this letter, the last letter shows the character that a particular variable or global variable can store in the ASCII system. So each character is a byte. So it also costs you to store data in a smart contract. It also costs you to store data in a smart contract. That's why it's also expensive to actually do change the blockchain, because if it costs you to actually change something on a blockchain, then it will cost you a lot to like corrupt the blockchain. You will use a lot of money to just change or corrupt the blockchain. Yeah, so it's actually good to accept how blockchain is and use it the way it is, because it will cost you a lot. Because as you can see, all from what we have been of or from what I've been talking about, it costs a lot of gas to actually store information on blockchain. Yeah, so the EVM has a word size of 32 bits, so it is optimized for dealing with data in chunks of 32 bits. So compilers such as Solidity have to do more work and generate more bytecode when data isn't in chunks of 32 bits, which effectively leads to higher gas cost. So some of these contracts, or some of the developers who create smart contract, sometimes they don't specify the characters or the size of their strings or their byte variables, and that makes the solidity to actually like it doesn't know, so it allocates. Think of an accountant not knowing the budget available. So the accountant will actually allocate a lot of money into that project, because they can either allocate more budget onto that project, or they cannot allocate a lot of money on that project, because they are not familiar. So it's like you are giving the compiler another work to like uh, guess what size your bytes should be, or what kind of storage should I allocate for this particular variable. So and that ends up creating a lot of gas, and you don't want your users to like complain there is a lot of gas on this smart contract, such things. So you have to be careful with your variables. You have to be careful with how you define your variables, and you have to specify the words, not the words, but the characters of that the variable should store. Then moving on to the next slide, we have gas cost. So hello,
Hello, sorry.
yes, yes.
I on that by 32.
Mhm,
Yeah, my question is this:
mhm.
would there be a problem if the number of byte size is less than 32?
So long as you specify the number of letters you want your, like, for normally, even in normal programming, that is web 2,
Mm.
we normally specify for like passwords. For password, we kind of say that you need to like enter minimum password of 8 characters. Yeah. So that will be like byte 8 bytes. So those are 8 characters. And then for username, we for normal databases, we allocate to 5 character, a character of 25 255 255 or 256. Let me see. Yeah, we normally allocate that amount of characters. So for 255 bytes, so mm, cha cha cha. So child of yeah. So the limit is actually 256. It's not 255. So these are characters for like names, mostly for name, for the dot, for the normal databases. This is how the string will be like. So you can actually reduce to like 50 characters if you're sure you are most of your username. If you are sure that most of your usernames don't have long names. There are people who have long names, like it's a sentence to say their name. So like, yeah, so you can actually decide. And even a space is also part of the character. The spacing is also part of the space. The space is also like it's also a storage. Yeah. So when you are creating your system, you really need to like come up with a work plan of all the variables that you want to store, all the data that you want the contract to actually come up with. And but if you now get familiar with creating the smart contract, there won't be a problem, because it will be like automatic. And for emails, it's around 50 characters. It's around 50 characters with a combination of symbols and letters and numbers. So that one is the length of emails. Then for something like a blob or an image, you can actually allocate something like 256, because sometimes you may be stored. It's actually advised that you store your images in links. You store them separately, like in a server like Cloudinary, and then you require them on your system using the link, because it's a good way. It makes the application load time reduce. It makes the application load time to reduce. So those are some of the things that you really like need to consider. That's why you find that something like Facebook or Twitter or even LinkedIn, the load time for those applications is very fast. You don't want to disappoint your users with images that are loading slow. The application is loading slow. The images are not loading, and yeah, so you need a separate server or a platform to actually upload your 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 images and videos. Yeah. So those are some of the letters and characters that you need to optimize. You need to optimize your word size when you are creating a smart contract. So you can imagine when you are like uploading a video of 7 point something, not 7, like 20 GB, a video of 20 GB, and you are uploading that 20 GB to a smart contract. That is a lot of space going into a smart contract. So you need like to store it somewhere else, like in YouTube, and then copy the link and paste it there. You can paste it there. But with IPFS, then there is an advantage also with something like torrents. You can be able to like you can be able to like also you can also be able to like save your videos there to torrents. Yeah. So these are some of the things that you really need to consider, and that's why some of the contracts are expensive, because of the kind of operations that they are using. Apart from the miners actually hyping the gas fee or the proof of stake, also the smart contracts themselves, uh, the way they are designed, they might be the type of the operation the smart contract is doing, or it's have, then it also makes the gas cost go higher. Yeah.
It's okay.
Yeah.
Thank you.
Yeah. So yeah, those are some of the things that you need to consider for even the Web3, the Web2. Even if even in if even if you are developing on Web2 or Web3, so those are some key things that you need to consider. Then we have the gas cost. So the gas cost is it depends. So we have 2000, 20,000 gas when a value is set to non-zero from zero. Then we have 5,000 gas when writing to existing storage or setting a value to zero. And then we have 15,000 gas refund when a non-zero value is set to zero. So you can actually get your funds back if you don't have the transaction was reset to zero. Uh, let's see the gas price for today. So yeah, I'm still connected to the local network, and just wanted to see if I can be able to send and see the today's gas fee. Yeah, so it's around 2021. So that is the current gas price or gas cost. So sometimes that was in 2018. The gas fee was around 2020. Yeah. Then we have actually seen how modifiers works, function modifiers. And then we have seen a constructor called once during contract creation. So a constructor is actually called once. And yeah. So we have also seen how to call a method from another contract. Yeah. We have seen how to call a method from another contract with the contract, the bank contract. So this is function F1, and then here we are calling the function F1. Yeah. In our bank contract, we were able to check value from to check the value of a smart contract, the value of our the value of the amount which was in our account. And then we have this one is on inheritance. This one is on inheritance. So I'll share these notes, and you can also practice some of these codes on your free time. You can practice them, and yeah. So that marks the end of our lesson on smart contract. So we have actually done a lot this week. We have talked about the benefit of smart contracts, uh, being 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 transparent, being immutable, cheap compared to traditional smart contract. We have also seen how to write a smart contract. We have also seen how we can actually inherit another contract, how we can do different methods, functions, and predefined variables. So today I'll take you through the list of the variables or the data types that are available. So we actually saw the boolean. So boolean returns a value which is true or false. We also saw about an assigned integer and assigned integers. So this one are already assigned. You can also assign this one. You can also assign it. Uh, but mostly the unassigned integer is negative. Not negative, but positive. It's by default it's positive. The unassigned one. It doesn't have any sign in front of it. And then we have the int, which can be either positive or negative. And then we have a string. So this is a string with 32 bits. So it goes all the way to 32. And then we have uint 8, which is an array of a string. You can pass your strings there. So this one, with an array, you are able to like now have a bigger space. So this array, you can actually add the size of the array like to 5 or even 500. So an array offers you the best. An array offers you uh, an advantage, because these other ones like bytes 32, you see it's limited to 32 characters, but with an array you can be able to actually extend the size of the array of your string. If you want the smart contract to have like a paragraph, and you know a paragraph contains a lot of words, uh, like 300 words to 100 words. So you need to use an array that can be able to like pass characters of like 100. So you can be able to like see the size of of your your value. So this one, we have a byte, which is one character, like it can represent one character or one value. The same case for this one. You have this one does not actually specify the length of the characters. This one is an example of how you now give the compiler the power to like decide what byte size to use. By default, it should be something to 32. It should be 32. And then we have bytes one. This is one character or one letter. And then we have byte 32. And then here we have the fixed with the number of decimal points. And then we also saw enum, so we can have an enum of actions like add, remove, update. And then this action, action, we can now call the action another, we can now define another variable, uh, my action, which will be equals action dot add. So then we can have another another action like that, and call it my action, my action, my action 2 equals action dot remove, action dot remove. So this one helps to like be able to like define an emulation that makes it easier for like status remove, status update, like for status update. So if you want to update a student fee, like having been paid or not paid or pending, something like that. So enums are good for checking such status. Then we have address. So this one is the address of, let me just a minute, I switch on my light. Okay, so address, we said address is the address of the user. So it can either be, either be any address. So you can pass any address either as can either be any address, either passed as an input or cast from a contract object, has a number of attributes and method. So any address, this can be representing any address. So let me just show you the uprecoin contract. And so you can actually have a defined address, like this one will, now you will be able to like assign, but you can actually assign it there and say this is your like this, neither, yeah, like that. So you can assign this, you can assign a value to this address, you can assign a value to this address. So this one we can like if we want the owner address to be already defined, owner address. So this will be the owner's address. We want to like, we already have a smart contract that we are creating, and we do not want the contract to be the smart contract's value. This one, we don't want the value of the smart contract to be the owner, to be the actual we don't want to the contract to, or the compiler to assign the default logic of the address, because sometimes it assigns the message of the this sender, this one. Sometimes it assigns by default it assigns this address, and we wouldn't want that. So you can define it or leave it empty. So to show you an applicable case, should be as the contract now, not this one. Yeah, this one. Contract. So to show you like an example of a good application, I applied it on the Ubricoin smart contract, whereby I defined known contract for so as you can see, this is these are some of the functions that I was talking about, and this modifier was is like looking for like if the contract is halted, and it can only apply when there is an emergency, and only the user, not only the owner, can actually perform that function. Like the owner of the contract is the one who can hold and unhold the contract. So that is the advantage of defining such. So I'm looking for the owner's contract. Yeah, this is the owner's contract. So this is the owner's contract or ownable contract. And here we have defined the address, or I had defined the address as public, and it's the owner's address. So this is the original owner, and the reason why we had created it like that way is that only the owner can be. There are those tokens that are mintable tokens. So next week we will be able to like talk about the features of tokens. And there are tokens which you can be able to mint. Like Ethereum itself is a mintable token. It has a total supply which is not fixed, and you can be able to like mint tokens, but they are minted under conditions. They are minted under condition. So for this one, we wanted it to be, we wanted the owner to kind of be able to mint and also be able to hold the contract in case of an emergency. In case there was a bug in the smart contract, we could be able to hold the smart contract. So this is an example, or a complex way now, or an advanced way that you can be able to like create a complex smart contract. So this one had so that is 1, 2, 3 holdable, and then we have 4, and then we have like 1, 2, 3, 4. We had 4 contract, and 5. The last one was the 5. So these actually are simple, a very simple smart ERC20 token. And as you can see, we have the UBN, like the token parameters, like what I was talking about. So this one has it already has a value, and then we have the symbol of the contract, and then we have the version as string. So the moment you enclose characters, whether they are words or whether they are numbers or symbols, the moment you enclose them with a quote, it means that that is a character. But if you are now creating like a public constant, or a constant that is constant late, this one is constant, it doesn't change. It will be 1000, of which means that 1 ETH is equals to 1000 Ubricoin. So if you have 1 ETH, you will probably get 1000 Ubricoins if the market like price was correct. Then we have another one that is constant minimum token that a user can be able to hold. So this one is like 0.1. You can like hold 0.1 in this particular smart contract. So this is how you like define your smart contract, and you specify. So we had also specified the available founders supply. So this one is these coins were then to be subdivided from the original total supply, that is 10 billion. That was 10 billion. So the initial supply to be released at token distribution, and then the founder supply was to go to this particular address, and then this particular address was to be closed. This particular address was to be closed, was to be locked until a particular period of time, and then these tokens were to be released. These it was almost something 1.5 billion, 1.5 billion were to be released after a certain period of time, and then the same case for the other uh, the other the other tokens, that is the airdrop supply, was to be locked in this particular address. The owner supply address was supposed to be locked to this particular address. So I'm just showing you how like you can be able to like use this global variable address, and then here we have an array mapping of the token holders. This one we have a list. It's a list of the holders. So this will be all the list of the available holders. So if we go to our contract to lead the contract here, hello, hello.
Yeah, we are with you. We are with you.
Oh, okay. I thought you were asking a question. So
No,
if
no,
we
no,
go
no.
to the lead contract, we can be able to see this is the address that will be holding those particular coins. And then we have the ICO address. So the ICO address can be the contract's address. Yeah, so this is how you are able to like manipulate your smart contract, and also like be in control of the the so that you can be able to be in control of your maybe your tokens, and yeah, so that normally you don't like store like I mentioned, you never store your variables in one basket. That is your eggs in one basket. So yeah, this one you can be able to like view the address in different. This is a new feature, so you can be able to view the smart contract when it was deployed on testnet, and when it was deployed on either scan. Yeah, so it's something that they are doing so that you are able to monitor if there is another contract that is the same. Yeah, so that is the address. And then we have this other function which is public, and it's a function that assigns this value, the address. So it's going to default and select the address of the deployer, or the person who is deploying the contract. So as you can see, I had previously assigned this. It assigned the value to my address. Yeah, so it was, so the value has been assigned to this address, the address that we normally deploy with this one. So if we try to assign if we try and change and use uh, this other one, the one which is below, and then we do the deployment again, that address, and then we view our, so if we do the assign address again, it will automatically assign this address. This is the 0AB8. So it will assign by default, it should assign the address of the person who have deployed. It can also be, sometimes it can assign the contract address. Yeah. And then with a value, so it will also, it should also output the balance of the address and also do a transfer. So it have actually done a transfer, as you can see, from this address to the same address, because we are sending to ourselves. So it has done those two things. Yeah. So that is the function. By default, the address of the contract that is available, or the address of the person who is deploying, or the contract address. And then we have an array here. We have another array of integers. So basically this one is for integers. We saw the other one for strings. So another one for strings here. So this one is for strings. It's an array for strings. That's how you define an array for string. And this is how you define an array for numbers or for integers. Then we have this one, function array. So you can push my integer dot push. This will be pushed to the first string. So the input will be pushed to position 1, and then this will be the length of the array. We'll be getting the value of so an array, normally how array, or how you get array, it's you remember when I mentioned about binary and heads when we were doing cryptography. So when we were doing cryptography, I mentioned about binary and hexadecimal and octodecimal. So normally in computing, numbers starts from 0. The same case for array. So when you are mapping your array, you start with a 0, and then 1, and then 2. Yeah. So yeah, this something, if you are a programmer and if you are a software developer, it's something that it's default known that when you are mapping an array, or when you are like consuming an array, you actually sorry, you are pushing, you are starting, you start your counting from 0 all the way to now the prime numbers. Yeah. Then if you are pushing another, if you are pushing a value, you can push it to like now column 1 in the array. Yeah. So don't be don't be like don't be good. Don't confuse these numbers like 1, 2, 3. Don't confuse them. So if the data which is being pushed here, this one will change to value 1. This one will change to value 1. Yeah. And then we have a fixed array. So this one I have mentioned. You can have a fixed array with the characters or the length of the array. Then we have abstract. So we talked about abstract. So it's a grouping of related variables. It's a grouping of related variables. So we can have an account. So an account, if you open an account, it normally has your email address, it has your name, it has your balance, it has a lot. So you can actually see the struct here. So it should yeah. So yeah, these are simple struct, and then we have the account. So you can now assign the values of that account. So this one should actually show the balance of this person. Can actually show the daily limit. You can do the same thing like my account dot daily limit, the daily limit that particular person is supposed to like have to withdraw. That will be like 10. Yeah. So that's how you can actually use them in a in a in a in a function. That's how you can use struct in a functions in functions. Then we have, lastly, we have the mappings of the accounts. Hello. Yeah, so sorry for that. So we have also seen the mapping, and the mapping is a mapping of all the addresses, and yeah. So this one from the struct, we can now do a mapping of the accounts that have been opened or created on our smart contract. And it's important to do that because you also want to track these data so that you are able to like display on your end on your front end side. So like for this, there was a system that I was creating, and we have done the mapping of that data. So this data, this is how you are able to like, so that you can be able now to display this data this way. So this is a mapping of this data, and yeah, using the mapping. Then we have function payable, or a function which is payable means that you can be able, you can you can actually send money to that particular function, and you can be able to show the balance to that function. So your smart contracts need to be payable, and you need to create a function which is public, so that your contract can be payable. And then we have the last one is the function to get the balance of a particular account, or an address. So since we had actually set our address as 0xab, we can actually get the balance of our contract. And for now, we have zero balances on our account. Yeah. So that's it on data types. That's it on data types. And yeah, that's it on data type, and that's actually marks like the end of our class on smart contracts. And yeah, so we have actually done a lot on smart contract. We have seen the inner workings of a smart contract. We have seen who introduced the smart contract, that is Nick Zabon. And we also saw the benefits of smart contracts, how we can be able to compose. And lastly, uh, what I want to conclude with is the limitation and security in smart contracts. So smart contracts alone So we have limitations and securities on smart contract, and there are things that you really need to consider. So smart contracts alone, one is that smart contract alone cannot get information about real worlds, like events, because they cannot send HTTP since they cannot send HTTP requests. So in Web 2, we normally have HTTP requests. That is the APIs. APIs normally send HTTP requests, and they are able to get information about the real world. But for smart contract, they don't do that. And that's why we say as long as we are creating systems, or we are creating smart contracts, and like the system I've shown you, you need to come up with you need to combine the two, so that you can be able to create a system which is interacting, or a smart contract which is interacting with the real world. Like the system that I'm creating for the water company, I'm combining Web 2 and Web 3 to come up with a system that can be able to interact with the real world. So generally, if you are interacting on if you have seen how others can look like, this is how you are able to like interact with it. And it's not a good way. It's not a good way to like interact with a smart contract this way. But with this one is a little bit better, and you can be able to like the BA. Yeah, so this way you are able to like interact with the smart contract, and without knowing the inner workings of the smart contract, without even having to know the inner workings of the smart contract. But with Linkbay or mainnet, you are actually interacting with the contract directly. But yeah, so that is one of the limitation of smart contract. So this is by design. Relying on external information could also jeopardize the consensus. That's something else, which is so that is something that was created intentionally by the Ethereum guys, so that they shouldn't send HTTP requests also, because one thing, most attacks in real world happen on HTTP websites, especially websites like WordPress, generally made using here using PHP, and HTTP requests are vulnerable to attacks. Uh, yeah. So, and also to protect consensus mechanism, the consensus which is being used, which is the major point on security. There are ways to get around this using oracles. So oracles, that's why we covered oracles, because they are important, because they will be a way now to like actually interact with the human real world information, or to get real world information. And then we have security. So smart contract security technically works via the same concept as the security of any software: coding, testing, ensuring, and specialized specialized security insurance exists. And due to the young crypto market, smart contract failure insurance company I'll imagine. We have Open Zeppelin, which is a company that majorly works on securing smart contract. They scrutinize and they validate your smart contract. They audit your smart contract to see if the smart contracts are following a procedure, or are immune to attacks. Then we have writing secure code. So the very first step of a secure application starts from within. So you need to like know which kind of cryptographic mechanism you want to use on your smart contract, so that it becomes secure. So the code itself, if the code is not created with the best programming practice, it widens the attack surface of a potential attacker. So it becomes even easy for attackers to actually see vulnerabilities in your smart contracts. And remember, always put this in mind: the kind of smart contracts you are creating, you are not creating the smart contracts for fun. You are actually creating the smart contract to manage people's money, to manage people's asset. So if this contract is potential to attacks, then the blame will be on you. So it's also your reputation, which is at the masses of the smart contracts. So especially if it's accessible on the internet, like smart contract, Ethereum knows this and has published guidelines which assist to create smart contracts. So it's always to also follow the guidelines provided by Ethereum, and also organizations like Open Zeppelin. They have standards. We have the ERC 20 standards. We have the non-fungible standards. Make use of Ethereum.org. Ethereum.org and Ethereum documentation. Make use of those websites because they provide a clear way and a good understanding or a good guideline on how you can create different smart contracts. And also, if you are not sure, also consult a consultant and see how you can be able to they can be able to assist you. Yeah. So testing the code is one of the major thing that also you have to do. So you have to test the code every time you write. So code tests are another piece of the puzzle. So whatever we have done on link bay or here remits, then is other ways you can use Mocha and Chai. Mocha and Chai, the programmers do really love to eat. Programmers do really like to eat because from ganache to mocha and chai. Mocha and chai are for unit testing. They are basically used. They are JavaScript libraries used for unit testing. You can use them for unit testing your smart contracts. They are basically not JS libraries that you can be able to use. So Mocha and Chai are mostly used for testing. So this one you can they are simple to use, as you can see. So you can define on your editor, define and then describe. So this one should return a negative value when the value is not present. It should return negative. And then once you learn, it should pass. It should pass. So there are some people who like tests that how do I put this? There are people who do unit testing, and when they are doing unit testing, the unit testing does not pass. Like it fails the testing test. It's like failing the testing test. Like you are failing the test that is supposed to test whether you are good. Yeah, so that is Mocha and Chai. And then we have, oh, sorry. Then we have, where were we? Yeah, there. So we have code testing. Code tests are another piece of the puzzle. They are essential for secure software. Here, the runtime execution is tested. This can be done on your own, but it's best to also consider an experienced companies like Satic and also Open Zeppelin do also testing of your smart contracts. Yeah, so I don't know. Yeah, so this one is reading a security reader board in auditing your smart contracts. And yeah, so if this is why I also told you that you have to know who have audited. As you can see the reading projects in terms of security. So we have reading projects in Ethereum, and we have others in the Binance Smart Chain. So as you can see, we have Pancake, which was audited, and the security score is 92. We have Ave, 88. We have others. We have the chain, we have Curve, we have Binance itself. So you can see these are guys who are leading in the leaderboard in the market with in terms of security, in terms of everything. We have Satic itself, their coin and their smart contracts. Uh, I want to share the I want to share these links so that you can also be able to like open zeppelin.org. So these companies do smart contract auditing, and yeah, these are some of the things you actually need to like consider when you are also invest in the security of the smart contract and their score. So you can see that these projects are not by luck that they are popular, but they are popular because they have also gone through this security test. Polygon is one of the networks. We have Matic, we have Shiba Swap, we have DAO Marker. Yeah. So these are some of the things that you also need to like check whether a company has gone through such security checks. So of course, our coin has not gone through this. And then we have this on Binance Smart Chain, the projects which are available there. So these are some of the coins and tokens that have been created on Binance Smart Chain. Yeah. And then we have Open Zeppelin. Open Zeppelin is also for security audit. They do security audit, and then they have libraries that you can be able to use that are already created for you, and they offer guidelines that you can be able to use when you are creating your smart contract. Then we have the Ethereum.org. Ethereum. Ethereum.org for developers. It's a documentation. You can learn more about Ethereum, about different tools and different the standards of like this one is on introduction on smart contracts. So you can learn about compiling the anatomy of a smart contract. So we have actually done that. So this is how the smart contract looks like. This one is for Viper. This is an example for Viper. Yeah, so we have talked about memory allocation and yeah, so we have actually talked a lot about what is in this documentation and how to actually define this. And then we have libraries. So we have talked about libraries, and they are the same. They are the same. You can also follow the standards that they have provided. Yeah. So these are big documentation. When you are creating, you can use it. It's like fits in a jigsaw puzzle. So you need to like lead from different places so that you can come and create a full picture of the blockchain. So they are scattered outside there. So this one applies when you have reached, like your contract is out there and you want it to be verified. So blockchain is a serious it requires seriousness when you are developing, and it requires you to like spend a lot of your energy on developer, because community, if a project is good, community will always bring itself. But for if a project does not have developers, then you see what it has a lot of things to lose. Yeah. So that's why those guys are being paid lots and lots of money, because you have to like go and create a perfect system. Yeah, then we have web3.js. So this one is written web3.js. So this one is also another documentation. So this one is another documentation where you can read about Web3, about how to like, this one is it's good for when you are using it for displaying information and consuming the contract. So uh, you can be able to like get the address of the contract using this method or function, this function. So web.eth.contract object makes it easier to interact with a smart contract on the Ethereum blockchain. So this another documentation that you can read, and it will be part of the next lesson when it comes to DApp creation. Yeah. So yeah, let's share the ethereum.org docs. Uh, on chats. So ethereum.org. Have I shared Open Zeppelin? Let me share also the Smart Zeppelin. Open Zeppelin. So here you can learn about the security audits, how they audit. Of course, they do it at a fee. So your team fixes the issue. So they will actually send a report of what your contract is like, and yeah. So these are some of the most popular companies that have been audited. You can see all the audit reports of a particular. You can be able to like read the audit report of the Solidity itself, Solidity compiler audit itself, Maca. MacaDAO has a critical vulnerability. Then center token mining contract audits. And also to confirm, you can actually confirm here DAO, MacaDAO, this one. So you see, they haven't. Not this one, MacaDAO. Let's just search it. They have had 4 audits. They have a I think they have a problem. Yeah, it has actually been resolved. Yeah. So this is how you are able to know. So Zero was also audited. Zero was audited. We had Alpha Homara was also audited. So this is Ladies 4, Ladies version 2. This is the graph. It was also audited. Graph has been audited a few times for their different things. So there was a bug in staking, and they fixed it. So this is how you are able to like your favorite coin that you are holding, the coin you are holding. This is how you are able to see if they have been audited. And you see, these audits are public. No, they are public, and they even offer rewards if you are able to like you are able to solve you are able to find bugs in the bugs in the system. They offer you bounty in once you are able to find, they pay you. Yeah. So yeah, I'll actually read some of these reports and see what I can be able to like contribute. Yeah, so this is static, and yeah, then we have another limitation, and insuring the code. So this is quite an interesting angle to smart contract. So smart contract insurance. This one is an incoming one. Actually, I haven't heard about this one. Bridge Mochu. They could have covered the previously mentioned harvest finance hack. According to their pitch deck, insurance are known to be used in various areas like health, automobiles, or work. Clients get insured to have a level of safety about their time spent in those areas. So with smart contract use lies in smart contract failure insurance may become more important, especially for companies with large pockets. So this something that people can be protected from if a smart contract has a hack and a failure, and you need an insurance company covering that. So yeah, we have insurance companies, so you can create an insurance company on smart contract and ensure that that will be uh, 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 I don't know whether would be logical creating a smart contract for insurance and then insuring the smart contract. Yeah, so you can actually find their pitch deck. Let me just share the link of this bridge. So these are some of the limitation and also security measures that you need to take care of uh, when you are creating your smart contract. So we have actually covered a lot and we have seen a lot, and yeah. So let me see bridge. To, mm, yeah, these are the actually a better way to like ensure your your smart contracts. Yeah, software need insurance because yeah, so you can learn more about this one. So it can protect all your crypto assets and earn profit in exchange for coverage, liquidity, and yeah. So yeah, these are some of these are some of the uh, uh, these are some of the opportunities. So you can even think of creating an insurance company here in Africa that actually covers all insurance blockchain tech, because we have seen companies create smart contracts here in Africa, and then the smart contract fails and the company get lost. They lose money. Yeah. So these are some of the due diligence that you need to do when you are creating, and also when you are doing investment in blockchain. Yeah. So that with that, we have actually come to an end of our smart contract session and lesson. Yeah. So we have actually learned a lot. Yeah. Apart from drowning. Hello. Hello.
Hello, where with you?
Yeah.
Where with
So
you?
yeah. So it looks like Damal is dropped. Yeah, so in case you have a question, concern, comment, observation.
Yeah, no question. Everything is clear so far. But you can help us share that the slide.
Yes,
Hello?
hello.
I said no for my side. From hello, can you hear me?
Yes, yes,
Hello? Yeah,
yes, I
for
can
my
hear you.
side, yeah, for my side, no question. And you can also help us drop the slide for today's for the conclusion on the syntax.
Okay, okay. I'll share this one. I'll actually upload it right now, uh, so
Okay.
that we can be able to like use it.
For our assignment.
Yeah, for your assignment. I also wanted to speak on the assignment. Yeah, I wanted to speak on the assignment, and don't know if Damales is joining us again. Let me ask her.
Okay.
Yeah, so that mhm, uh, I just explained. So and then she will refer to the video. Okay. So on the assignment, on the assignment, I had I have the assignment is actually simple. Uh, you you need to create a simple smart contract to store this and display and send data. So you can actually, yeah, to store and display data. So this one, you can just create a simple smart contract to actually store your name. And if you want to make it complex or complicated, if you're good, uh, if you go through the documentation, then it will be awesome. And then you have research on more on Ethereum smart contract, and also come up with a simple smart contract. The using the standard functions to make a simple token. So yeah, this one this one I will actually check, because it will be on the basis of it will be the base of our next lesson. This one, Ethereum tokens. So it will be the base of our next token, our next lesson. So if you are able to like be able to like read that documentation, it will help you in understanding. In understanding, yeah. So it will help you in understanding. Trying to like so that I can be able to see if Damres is joining us again. So it will help you in understanding various concept of NERC20 token. Yeah, it doesn't matter if even if you come up with 2 to 3 functions, it doesn't matter, and then you will have to share. Then there is something that I've written here. What is double spending? I've actually shown you the answer. The answer is right below the slide.
Okay, so who book exam?
Yeah, but also you need to take a look at the benzenite fault tolerant system, or benzenite tolerant system. You can read more about it, and also you can include it uh, in your assignment. You can include it in your assignment, the benzenite fault tolerant system. And then double spending, document more on double spending, because these are some of the key things blockchain is trying to solve, the benzenite fault tolerant, and also double spending. So double spending is actually derived from this benzenite fault tolerant, and see how the what do we call Shanzu, yeah, Shanzu on Art of War, yeah, call him Shanzu, and how they were able to use the benzenite, and yeah, so Shanzu was a good war strategist, and yeah. So then on I don't know, trying to look, there was a, yeah. So consensus mechanism, we will be able to learn about consensus mechanism on our next topic. So this is lesson 6, and then so we are actually about to graduate. We are like 2 lessons to graduate, yeah, and we will be blockchain experts, yeah.
That's interesting.
Yeah, so those are 2 topics away to be blockchain gurus. Yeah. So yeah, so this is the assignment. So a simple smart contract that stores and displays and sends data, and also research more on Ethereum smart contract and come up with a simple smart contract that is using the standard, the ERC20 standard, a simple coin. Then what is double spending? Just answer that question. It's more of theory and more of research, and learn more about the benzenite fault tolerant. Yeah. So that's it on the assignment, and yeah. So let me add the syntax, add the slide on the syntax, and then will be good to go. So you can actually use some of these contract, light simple codes, and learn different implementation, how to implement different things. You can even make it a little bit complicated, and add something on inheritance, yeah, to just display what we have actually learned, to show that you have gotten the concept of creating a smart contract and such. Yeah. So I think I'll have to like repeat since Damalis has joined. So let me share the screen again. So Damaris, I've uploaded the PDF on the syntax, and yeah. So I was actually explaining on the assignment and the guidelines. I've shared the links that I've shared, that is on the Ethereum org. You will need to use the Ethereum org, and also use the Open Zeppelin. Let me share the GitHub repo, also the Open Zeppelin repo. Open Zeppelin GitHub repo. So here, these are a link where you can be able to like get the ERC20 standards for assignment number 3, for question number 3. Okay. So for question number 3, you will need to use Open Zeppelin and also ethereum.org to learn and see the different standards, the different functions that are used in creating an ERC20 token. You can also go ahead and at least explore and see the non-fungible token. So it's not limited. You can see the standard for non-fungible token and also the ERC20 token. And then this one, the first question, you will need to use what we have done, the codes that we have been writing. That is the one that I created on the very beginning of this week. That was on how to store information, how to send data. Yeah, the one we were changing the name, the ADS name. Yeah. Then I've also explained where you what uh, I expect on what is double spending in blockchain. So actually, the answer is here, but you can get more answer and more understanding of the question on what is double spending, because double spending is the major problem blockchain tries to solve. Yeah, so you need to get to know, and there is a historical background on the problem, that is the benzenite fault tolerant. Yeah, so you can read on it, and yeah, so that's it on the assignment. So I've shared the PDF on the syntax. Yeah, so this marks the for the question number two. Question number two will be the basis of our next lesson. It will be on the basis of our next lesson. That is on Ethereum tokens. So that's why, yeah. So you need to research, at least know the different types of functions that are used in ERC20 and NFT. And yeah, so under Ethereum token, we will also see the different consensus mechanism. Uh, we'll also talk about the various type of tokens. That is, tokens differ in how they are created. So we have the utility tokens, and we have the security tokens. So a good example of a security token is is it polymath, polymath. There is polymath and polychain. So polymath is an example of an security token. Yeah. So we will see the different and the different ways they work. Yeah. So we have two lessons to graduations. Yeah. And then by the end of this course, you will be ready for you will be blockchain experts. Yeah, you will be blockchain experts. So you can actually open your 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 farm for security audits. For developers, you can create yeah. So there is a lot of opportunities in blockchain. You just need to like specify which field you are good in blockchain, and then actually it's a more of like, if you already have a career, it's like now you are now incorporating blockchain to enhance the career you are already in. So initially for me, I was a web 2 developer. I was developing using the normal technologies, and I've advanced to be a Web3 or a smart contract developer. So I've specialized in smart contract development, especially the backside end. And also, I'm doing not crypto, but blockchain education. So I'm teaching about blockchain. So you see there is a role of, you are just enhancing on adding more attributes to the career that you have. Yeah, if you are a financial guru, like uh, like uh, like her name is Lozrin. Lozrin has a background in Lozrin has a background in finance, but now that the background in finance is the same concept which is applied in blockchain. So it's just the traditional concept moving into the blockchain. Yeah. So there is a lot of new terms to actually mean something that was done in Node, but in a new version. Yeah. So yeah, that's it. And yeah, so if you have a question, Damaris, or a comment or a concern, you can ask. Hello.
Hello.
Yeah.
Hello.
So if yeah if the floor is now for Damaris. If she has a question, concern, comment, yeah, you can. Yeah, this is an opening for you. Before we now call it a day.
I think so far it has been good.
Mhm.
But personally, for me, coding has been, it was very basics level. So I think that's the area maybe I need to work on,
Okay.
so that I can now be able to write contracts.
Yeah. Yeah.
Because I think the fact that I've been in the crypto space for long,
Mhm.
I feel like I'll still employ this knowledge around crypto and whatever I've been doing.
Yeah. 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 Awesome.
So maybe if, we can do some few of them. Maybe we give like assignments from maybe the basics as we progress now to the complex.
Okay. 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 I'll add I'll try and come up with another simple, at least another simple assignment. Yeah.
Is there a way you can also share the codes that we always go through in class?
Yeah.
Like
Yeah.
the
Yeah. Yeah. Was supposed to upload them today, but I've been having issues with my network. So actually, right now I'm using mobile data, and I was supposed to upload them to GitHub so that I can be able to share them in a chronological order. I have them in my folder, so I think I will try and upload them using this data that I have. Yeah,
Okay, I think that's fine. And maybe because I think Ambrose said he has done computer science or something, software engineering.
yeah, yeah.
Maybe
He
we
did
can
mention
also
that.
do some assignments together. I think he will also come in handy. He'll help me in some few areas.
Yeah,
We
sure.
can do some assignments as joint and others individually.
Okay. Then I think this other the question three, I think you can do together. Question three of the assignment you can do together.
That'll be fine.
Yeah, yeah, that will
Okay.
be that will be fine. I'll also share more resources on that. Yeah, I'll also share more resources on a simple like a GitHub repo. I'll share with you a GitHub repo where you can be able to like get more standardized the standards on a simple smart contract where you can differ. Yeah,
Okay.
yeah.
It's okay. That'll be
Also
more
for the
appreciated.
for yeah yeah also for the coming class that is on tokens. Most of it the a complete ELC 20 token you will actually do together. You can do it together. Yeah, can do it together. You can do as a group. You can do it as a group. Yeah.
Okay.
Yeah.
It's okay.
Yeah, I'm always available on weekdays. Yeah, I'm always looking for someone who we can get into a call because I normally code when I'm alone. So I'm always if you have any question or any help with coding or smart contract, I'll also be available. Yeah.
Thank you. That'll be fine.
Anything you want to say, Damaris?
No, I think that will be fine.
Okay, awesome. So have a lovely weekend and a lovely evening. So enjoy and be safe. Be safe.
Yeah, thank you. And you too.
Good night too.
Yeah, good night. Nice weekend.
Okay, good night. Bye.
Yeah, good night.